what we're looking at right now is a linear inequality, and we're going to try to figure out how to solve a linear inequality. And basically the question I'm asking myself is, I want to find all the values of x that make this statement true. And the best way to do that is to solve this equation, or this linear inequality, all the way down to where x is all by itself. In the same way we've done linear equalities, or basically equations. So to remove this or solve this down, I'm going to follow a lot of my same rules that we've had before. 3x minus 5 is greater than negative 17. Well, I want to isolate the value of x. Well, the first thing I should do is add 5 to both sides. So 3x minus 5 plus 5 is greater than negative 17 plus 5. And you can see that I added 5 to both sides. And adding 5 to both sides doesn't change the value of my equation or my inequality. I'm then left with 3x is greater than negative 12. Not done yet. I still need to isolate the value of x. So as I isolate the value of x, I probably should divide both sides by 3. In dividing both sides by 3, I see that 3 over 3 is my clever version of 1. And I'm left with x is greater than negative 4. There's several different ways to write this solution, depending on how it's being asked. One such way is writing it in interval notation. In interval notation, basically we're trying to figure out what's the interval between which low value and which high value do I find all my solutions. So right now I know my low value is negative 4. So I'm going to write negative 4 as the start of my interval notation. And my highest value that I have is, it tells me all x's that are greater than negative 4. So what's the largest value of x that you can think of that's greater than negative 4? Infinity. So in interval notation then, the solution set can be written as negative 4, comma, infinity. All the values between those two make this linear inequality work. Sometimes students may confuse this as a coordinate pair, but out of the context of the question, you should be able to identify, hey, this isn't a coordinate pair. We're basically looking for a range of values. Another way to write the solution is through set builder notation. And set builder notation is real similar to this. Set builder is saying, give me a rule and I can find out what all the solutions are. And how I read this says is all x such that x is greater than negative 4. And that's also a way to describe the solution. And that's called set builder. And lastly, you can also identify it through a graphical solution. I'm going to draw a number line that's going extending to negative infinity and positive infinity. I'm going to put in a couple marks, 1, 2, 3, 4, 5. There's 4. Going backwards, negative 1, negative 2, negative 3, negative 4, negative 5. Just enough points on there to kind of help us all understand what we're talking about. And this tells me that all my solutions are greater than negative 4. So I'm going to write it such like that, where I have a little bit of a parenthesis crossing right at negative 4 and going all the way to positive infinity. This solution would change just a hair if my original equation, I'm going to try to change colors on you. If my original equation was greater than or equals to, then we need to figure out how does that reflect itself all the way down through these rest of these solutions. Well, in interval notation, this parentheses, which is an open one, tells me that the solution approaches negative 4, but it doesn't include negative 4 itself. So if negative 4 was a solution, I would put a hard bracket or a closed bracket on there. In set builder notation, it's exactly the same, except I'll make sure that x is greater than or equal to negative 4, as is written on out. All x such that x is greater than or equal to negative 4. And then lastly, in the graphical solution, instead of this open bracket, can you guess what I'm going to put down there? I'm going to put a closed bracket in its place and draw an arrow all the way out. So an open bracket will tell me that's the end cap is not quite the end cap, it approaches it. A closed bracket tells me that that endpoint is included in the answer. You also see this infinity and interval notation. Since none of us that I know of can pinpoint infinity down to a very specific location or a specific number, infinity by nature will always be open-ended. So you'll never see a closed bracket with an infinity or a negative infinity.